Hi. Today, thank you for coming to our talk about OpenFeature's positive impact on the confidence at Dynatrace. I'm Simon. This is my teammate Todd. Today we will give you a short introduction about our journey with OpenFeature and feature flagging at Dynatrace. First, we will give you a little introduction into our history, so what we used to have till now. Then we will talk a little bit about our philosophy for our new approach and the general adoption story behind that. But before we start, here a little intro about ourselves. So I'm Simon Schrottner. I'm a senior software engineer and team captain at Dynatrace. Our team is actually responsible for adoption of OpenFeature internally and supporting the community. I'm also an open source enthusiast. In the meantime, also a maintainer of OpenFeature. And Todd is my teammate.
Yeah, I'm Todd. I'm also a senior software engineer at Dynatrace. I'm a member of the technical committee for OpenFeature. And I like to consider myself a spec enthusiast. I come from IAM background, so a lot of SAML and OAuth and those kinds of things. So I contributed a lot to the OpenFeature spec as well.
So let's take a look at the history at Dynatrace, how we used to do feature flags and what we had at Dynatrace before that. Let's inspect a little bit the good, the bad, and the ugly, and starting with the good. Well, we are software engineers, and we all love to keep our feature flags in GitOps style, like having a repository, storing everything there with all the neat tooling behind it, like auditing and approval workflows and stuff like that. And it was also quite cool, because with this GitOps approach, we can configure it per customer or per tenant, as we say. The bad thing about this, although, was that it was just Boolean. We had on-off. It was baked into our binary, and we could override it, but we still needed to persist it afterwards in our GitOps, in our repositories. It was a little bit hard to use because we lacked the inability to target specific users or to do progressive rollouts, and this was getting very tedious over time. And most of our backend services are actually written in Java, so it was a little bit problematic. Not problematic, but we only supported Java most of the times, and although we already have a lot of other languages in our stack. The ugly part is, well, it was maintained in source in Git, so we had the control there, but with hundreds of clients and thousands of flags, this got really complex and hard to maintain. It were just too many, a lot of them abandoned. We had no observability, no telemetry information, and the ownership was always questionable because a lot of team changes happened. To highlight this a little bit, some statistics. So we have currently around 2,300 feature flags in the systems, which is quite a lot. The problem in this system is actually that more than 700 have not been evaluated within the last 6 months. So the question is if we really need them. The even sadder part is that 1,200 have not been evaluated in the last 2 years. So it's highly questionable if we need them, but we are just too scared to remove them. And the oldest one is from 2018, which can be, of course, it could be an operational toggle, but if that's not the case, that could be quite...
Yeah, actually, this one is listed as a temporary flag. Interesting.
So our SREs who had to work with those feature flags were quite frustrated, actually, because it was a nightmare for them to maintain it. It was really tedious, and each change just took so long. And they was just simply too scared to remove flags or just decommission them, because sometimes they even do not know if they had some kind of side effects, because also some developers like to misuse feature flags for other topics because they match the name in their issue they had, actually. And our devs, well, for them it was easy. They could just create feature flags and use them in the backend at least. And the front-end devs and Python and others would have loved to be part of that, but were not included. To summarize this a little bit, it was really tedious, it was not really as powerful as we would love it to be, and not as flexible, and it did not really scale with our workflows. And that brings us to the next part, our philosophy and what we tried.
Yeah, thanks.
Or what we wanted to achieve.
Thanks, yeah, so like Simon said, this is the kind of philosophical part, so we wanted to kind of reimagine, I guess, what feature flags could look like at Dynatrace. And we kind of broke that into 3 sections, like the what, the why, and the how of a new implementation. So the what, you can kind of think about these as like requirements. They're pretty concrete and well known. So we wanted support for multiple languages for sure. We wanted to support changes at runtime. we wanted unlimited granularity in targeting. When we say targeting, we mean we want to be able to turn feature flags on or off, or provide different variants specifically based on contextual information. So, enable a flag for a certain geo, show a certain variant for certain devices. So we wanted unlimited granularity in targeting, not just tenant-based targeting, like Simon mentioned we had already. We wanted first-class observability. So that just means that we can see everything going on in the system. We have good metrics for all of our evaluations. We have traceability, that kind of thing. We also wanted support for experimentations and more importantly, initially just progressive rollouts. So the ability to roll it out to say 1% of the customer base, 10%, 50%, 100%, and simplified management. So again, Simon mentioned earlier, it was all based in Git before. That's okay for developers to a certain degree. There's scalability problems there, but it's certainly not very accessible for PMs and that sort of thing. So the why, these are the things that we kind of believe. We know that our engineering teams are going to benefit from a kind of a unified API. Like I said, we have a lot of different languages and projects in Dynatrace, and we knew that we wanted them all, even if they weren't working with the same language, to have kind of the same ideas about how they're using feature flags. We knew that all of our workload types could benefit from feature flags, and we also knew that observability was going to aid in a lot of things, but specifically the retirement of old feature flags, like Simon was talking about. We believed, again, that observability insights would supercharge the utility of feature flags. So the more we could see, the more we would use feature flags. We also believed that our engineers would make use of advanced targeting so that engineers would take advantage of things like geo-based targeting and that sort of thing. So we built that into the system, and we kind of hoped it would get used. We knew for sure they were using tenant-based targeting, but we hoped for more. And we also believe that we designed a highly scalable solution that was really fast. That was super important for us, even at scale. And these are hopes. So these are the little bit more ambitious or hairier assumptions we made. So there's really two of these, I'd say. One that was that our project management team would take advantage of experimentation. So that wasn't really something we were doing up to now. And actually validate their assumptions about what they're building with feature flags and experiments associated with those feature flags. And also that our engineers would always use reasonable defaults so that even if there's an outage in our feature flag system, it would never impact actual primary functionality of the application. So we assured this one mostly through education and also through a consistent API so people knew what these defaults were doing. So last is the how. So this is actually the methodology. In short, we used open feature components and some custom backend tooling on top of that. All open feature components. We did build our own UI, so it was specifically tailored to what we knew our devs would do using our kind of internal UI platform. And then we built a simple, scalable infrastructure on top of the open feature components. So basically, we're storing our flags in a custom database and then delivering them all through FlagD, which I'll talk about in a little bit, all the way down to the open feature SDKs. So really quick crash course on what OpenFeature actually is. It's an open spec that provides a vendor-agnostic, community-driven API for evaluating feature flags. So this is the thing that your engineers code against, essentially. It's all open source, and you can kind of plug that into wherever you're sourcing your flags from, which we usually call the management tool. So basic usage in Java, you can see we have an OpenFeature API instance here. We can set the provider. That's kind of the translation layer that tells the SDK where it's getting its feature flags from. And then you get a client. That's kind of the main object that engineers actually interface with to evaluate flags. And you can see that happening here on this last line. So there's a flag called v2 enabled. I don't really know what it does or what went into this decision. We have no idea. It could be just on, or it could be a complex rule in the back end. And we're also passing in the default value false. So that's Java, which is really important for Dynatrace. Like I said, most of our backend services are Java, not 100%, but most. And then React is the other one. So again, a very similar API, but more React-ish, if you will. Here you can see we're setting a provider again. We're using it in this page that's kind of feature flag sensitive. And you can see we're doing an evaluation here. It's the same thing, v2 enabled. We have a default value, and we're using, in this case, a hook because it's React. and rendering some content differentially. So flag D, I mentioned that earlier. This is like the brains of the feature flag solution, I guess you could say. It's a feature flag evaluation engine. So it's fully open source. It's kind of like a reference implementation for our spec. And it's cloud native. So it runs kind of like a daemon. It can be injected as a sidecar, or you can run it kind of as a service. But it's what does the feature flag evaluation. So yeah, you can think of it like Lego blocks for a feature flag system. Out of the box, it has a whole bunch of features it supports. So a lot of them covered our use cases, modification of flags in real time, lots of type support for different types of flags, context-based targeting rules, so target a user, tenant, geography, device, whatever you can think of really, and then pseudo-random assignments, fractional rollouts, that kind of stuff. So it basically hit all our marks for the features we wanted. And here you can see this is actually a configuration scheme for flag D. We have a flag here called new welcome banner. It has a couple variants. In this case, it's a Boolean flag, so it's just on or off. And probably the coolest part is you have built-in targeting. So the targeting specified here is in JSON logic. And basically what we're saying is if the user's email attribute ends with @domain.com, we're going to show them the value on, otherwise off. So this is the type of stuff that was essentially powering our solution. Our engineers didn't have to understand this stuff at all because we basically built these schemas in a UI with fancy drop-downs and all that kind of stuff. But this is eventually what was being stored and pushed out to all of our flag D instances based on what was configured in a little UI. Yeah, so this is, like I was saying, custom UI and backend. Just to make things maximally simple, we didn't expose those kinds of configurations to our devs. It was all just built in the UI, persisted to the database, and pushed out. And you can see kind of an architectural overview here of what that looks like again. So yeah, we're saving the flags to the database. We have a kind of a mesh of flag D instances, and they're all of our flag configurations are pushed out to those, and then distributed to the individual workloads, all again via open source protocols. So OFREP and the gRPC flag desync protocol. But these are all just pushed out to all of our instances in our infra. Yeah, so in short, basically, simple building blocks all based on OpenFeature, very flexible, very scalable. Kind of hit all of our marks there. Simon?
Yeah, let's talk a little bit about adoption and how this usually went. So at Dynatrace, when we want to adopt a thing, we go to our chief architects, bribe them with the things they would like, and then it's enforced for all our teams. No, just kidding. Dynatrace is really autonomous. Everybody gets his own pace to adopt to things. We try to standardize things a little bit, but everybody can slowly adopt. This also, this autonomous part is also a little bit of a tricky part of Dynatrace because some teams did not want to use the existing feature flagging system, the old one, and adopted more likely their own schema for that and had their own version. So we are trying now to unify that, and the autonomous part was a little bit problematic. What went well in this process? So before we started doing anything in the UI, we took a look at how our teams are using feature flagging and what they want to use and what are their use cases. We focused on that and focused on providing them a nice user journey. That was really important for the adoption. Our UI is really well rated and well perceived by our teams, and that's one of the things which allowed us to onboard them onto feature flagging in an easy way. Furthermore, we provided them some kind of preceded context evaluation. So they do not need to care about certain attributes. So we pre-filled it with the hyperscaler they are running on, in which kind of environment, what was the user email address. So they had just a simple using our dependencies and use those to get onboarded into this tech stack. Furthermore, we provided some. We heavily relied on open source components. We just flavored them a little bit with a Dynatrace flavor to make configuration easy, that this first initial requirements are easily met and they can onboard quite fast. And the flexible, this provider concept of OpenFeature helped us to migrate flexible. So some teams started to using the OpenFeature SDKs early without our solution and slowly migrated into them. They maybe use config maps or environment variables, but the provider concept and the already existing provider SDKs helped us here pretty well. Our system is also quite fast currently. So for the front end, we have around 20 milliseconds for a web evaluation. Our backend is below 1 millisecond for the evaluation. And what we also try to do is, it's not just important in this kind of case to have high response rate on the service, it's also important as a team with your customer service. And we try to be there really fast and really flexible, which helped us a lot for the teams to understand their problems and engage with them in the onboarding process. But also, there have been some interesting things happened to us. So the one part was actually our adoption rate increased quite quickly. People liked what we are doing, but it was too quickly for our team. We were just 5 developers, and getting insights into what they are doing was quite hard. We were also surprised by the number of flags and teams, what they are using and what they are doing. So currently we are at around 80 teams at Dynatrace with hundreds of flags, close to 1,000 flags, and we are doing some projects doing 60,000 evaluations even on the dev stages already. So there's a lot of things going on internally, which was really, really cool to see that the adoption was done in that kind of manner. And there are some really unexpected use cases which baffled us the most and which is quite of a success story for us. On the one side, people immediately started to asking for synchronized rollouts. We knew we need to have this, but we put that further down the line, but that was one of the first things people experimented with. Then there was the need for objects flags, where they said, hey, we want to have some kind of ranges, like an upper and lower bound for thresholds. Also, the funny part was we have this workflow engine where you can write JavaScript lambdas, and people started immediately using that in there to use feature flag for those lambdas. And one of the most funny things was large numbers, which surprised us. So people are really creative when it comes to storing information, and they started storing nanoseconds within our flags, and also byte sizes. So were quite large numbers, which also brought us to the problem that our backend service broke because we could not properly pass those numbers. They just did not fit into a double. So, but the good part here is feature flags as an open feature always falls back to the default. Or does it, Todd? Oh, sorry.
Oh yeah, so I mean that's kind of the interesting thing, right? So we had this early assumption like, okay, we're always going to default, right? Right? And yeah, it turns out we didn't always just default. So there was kind of like between your feature flag evaluation succeeding and failing, there's also kind of a third option. And this resulted in what we at Dynatrace call a critical incident. And that just means that a customer was negatively impacted in some way. Yeah, so like Simon was kind of alluding to, basically we didn't anticipate some use cases. So numeric flags were a big one. Times in nanoseconds specifically. Yeah, and I think it was like buffer sizes in bytes. So we had a couple of these really high values, and what was happening is our ORM in our backend was marshalling these into different Java types, and I think it ended up going into a big int or something like that, which we didn't expect. So that caused a 500 in our service, which, because of some other bugs and infrastructural challenges we had, created some requests to start backing up in our proxies, and then they started hanging and being really delayed. So instead of getting flag evaluations back on the front end in like 20 ms, like Simon was saying, they were basically hanging for a long time. And what happened is we also had some UI components in our React SDK and being used in our front end that were deferring their rendering until they got their feature flags. Well, that's no problem at all when your feature flag is being evaluated in 20 ms. When it's taking like a minute, that means that you see a loader or a spinner on some components waiting for them to render. Okay, so that was basically what happened. So here's like the summary, the quick takeaways, so maybe you don't have the same issue. It's really simple, basic stuff. Never forget to set timeouts, definitely in your infrastructure, and we had them there, but also in your front-end components. So like loaders and spinners and that kind of thing, they still need timeouts. Don't neglect to consider edge cases for your feature flag values. So yeah, some examples, like we already know, large numbers, but also very long strings, very large objects, null values, maybe invalid objects, those sorts of things if you're using object flags. And I guess the third takeaway is more of like a philosophical takeaway. a few small bugs that seem like they're not really a big deal can accumulate somewhat unpredictably, especially in high load, to cause a really monstrous issue. We knew about basically all of these problems, but we thought that it was no big deal, so we didn't rush our hotfix to production, and that kind of they all accumulated in production to cause our issue. I guess the bright side of the whole critical incident was it kind of ended up being some advertisement for our features, because a whole bunch of people who weren't aware of our solution suddenly became aware of it. And they were like, oh, we have this kind of mature, interesting feature flag and experimentation solution. Interesting. And we've had a lot more teams on board since then. We haven't had any production issues since this one. Everything's going really smoothly. And like I said, we have 80, or like Simon said, we have 80 teams now, and a lot more since the CI. So yeah, people are actually using our stuff to release more confidently in production, and we're even seeing some really basic experimentation starting. Yeah, I think that's it. So yeah, you see a summary there, and I guess the last thing to say is thank you, everyone. Does anybody have any questions?
Yeah, I have a question. So you said you were injecting like a standard set of context variables, like the geographic region and things like that. In what place are you doing that? Do you have like a wrapper for around the OpenFeature SDK, or are you like injecting that on the FlagDD level? Or?
Yeah, you can go ahead and take it. I guess you don't need the pointer, but it's not a mic.
So we are actually using FlagD, because FlagD can actually send some context enrichment data directly to the consumers. So FlagD is enriching this information, and we are configuring this centrally on FlagD, and this is sending then this information to the provider who is subscribing to the configuration. Yeah.
Yeah, that's how we do the static ones, and there's also more request-specific ones where we have some like request filter internal libraries that we publish. So like for Java filters, they're pulling out of a tenant header, but the specific like teams don't know about that. They kind of just put this filter in front of their Java. It's like a Java servlet filter, or like a middleware if you're used to Node.js, and it's just pulling out all these standard headers that we have in our infrastructure and injecting them into the request context, using all OpenFeature primitives, but yeah, with a filter basically.
Thank you. Hey, my name's Mike. Just a question to help me land. How big is the team that are working on it? How long did you work on it for?
How big is our team now?
So
team captain?
So currently we are, I think, 5 people. Let's stick with 5 people. We have had some fluctuation in the past year. It's quite hard to say, because on OpenFeature we're working for longer. The real project started, I think, a year ago to adopt this and to work for the team with all rolling this out. So we started in June, July, I think was the starting point where we started slowly to roll out to teams.
Yeah, about that.
At the risk of getting booed, did you consider using an existing feature flagging product, like Launch Darkly or something, rather than building?
We did consider it, yeah. And there was actually some teams internally that were using products. So we considered it, but for a number of reasons, we decided to kind of roll our own. We do have a fairly big infrastructure and really, really tight demands on performance. So that was part of it. But we also knew that we had the internal infrastructure and the development teams to kind of handle it. So I think it would be the cost considerations were probably lower for us than they would be for a lot of teams.
Yeah, thanks.
Any further questions? All right. Thank you, Todd and Simon. Thank you.
Thank you.